All right, get ready because today we're diving into some seriously radical internet ideas.
Radical.
Yeah, not just talking about, faster downloads or like
Right.
better Wi-Fi, but like completely replacing the system.
Wow.
We've got
That's ambitious.
scientific papers, research on how the brain works, and even some futuristic proposals
Really?
that sound like they're straight out of science fiction.
Well, what I find fascinating is this idea of moving beyond just fixing the internet to
Right.
actually building something totally new from scratch.
Exactly. So before we jump into all these crazy alternatives,
Okay.
let's quickly recap how the current internet works.
Yeah.
You're probably familiar with the basic idea of data traveling in packets.
Yeah.
It's kind of like sending a message,
Right.
piece by piece.
Like a complex postal system
Yeah.
where each packet's finding its way through a network of routers
Yeah.
to its destination.
Right. And this system.
It's organized in layers.
Yeah.
Kind of like a cake. The bottom layer deals with the physical connections.
Yeah.
Then we have layers for managing data flow addressing, and finally at the top,
Right.
the applications that we use every day.
Okay. So we've got this layered system that's been amazingly successful
Oh yeah,
at connecting the world, but it's also got its weaknesses, right?
definitely. Our sources highlight security vulnerabilities,
Yeah.
limitations in speed and accessibility,
Right.
and concerns about centralized control.
Right.
For example, your data often passes through servers owned by big tech companies, raising questions about privacy and control.
Okay. So knowing these limitations, researchers are exploring completely different models for a new internet.
Interesting.
And one of the most radical ideas comes from looking at the most complex network we know, the human brain.
That's where it gets really interesting.
Right.
Imagine an internet that processes information not in a linear step-by-step way,
Wow.
like a computer, but more like the brain, which can handle multiple tasks simultaneously across this vast network of connections.
So instead of having a central brain,
Right.
like a server, we'd have a distributed system
Yeah,
where information is processed everywhere at once.
exactly.
That sounds incredibly powerful, but also super complex.
It is, and it's still early stages. This is called neuromorphic computing.
Okay.
But the idea is to build systems that mimic the brain structure,
Right.
where memory and processing are intertwined.
Now let's get to the really fun part,
Okay.
the speculative stuff.
All right.
Our sources include a document outlining 7
Lesson.
potential internet replacements.
Wow.
Each one aims to solve the limitations of the current internet in a completely different way.
That's a real testament to human creativity,
Yeah.
seeing all the different ways we can envision a future beyond what we know.
Okay, first up, quantum communication networks.
Okay.
I'm sure you've heard of quantum mechanics.
Yeah.
The science of the very, very small.
It gets weird down there.
It does. And one of the weirdest phenomena is quantum entanglement, where two particles are linked
Right.
in a way that allows them to influence each other instantly,
Yes.
no matter how far apart they are.
Yeah.
Okay, you officially lost me.
Okay.
How can something happen instantly across vast distances?
Well, think of it this way.
Okay.
Imagine you have two coins, one heads, one tails.
Uh-huh.
You separate them, put them in sealed boxes,
Right.
and send one to Tokyo.
Okay.
If you open your box and you see heads, you instantly know the other coin in Tokyo must be tails, right?
Okay, that makes sense with coins.
Yeah.
But we're talking about tiny particles, not coins.
Yeah.
How does that work with quantum entanglement?
It's similar,
Okay.
but with quantum particles, it's not just heads or tails. It's like they're both at the same time until you observe one.
What?
Then the other instantly snaps into the opposite state.
Okay, so by linking these entangled particles,
Yes.
we could potentially send information instantly across vast distances.
Exactly. And that's the foundation
Uh-huh.
of quantum communication networks.
Okay.
They promise not only incredible speed, but also unbreakable security.
Unbreakable security.
Yeah.
Now, that's something I think everyone would be interested in.
Yeah.
But how does quantum cryptography actually work?
It exploits the fact that any attempt to eavesdrop on an entangled communication
Right.
would disrupt the entanglement itself,
Oh.
alerting both the sender and receiver to the intrusion.
So it's like a self-destructing message
Yeah,
that exposes any attempts at snooping. That's pretty clever.
it is.
So while practical quantum networks are still a ways off,
Yeah.
the potential is undeniable.
Yeah, it's huge.
All right, moving on to concept number 2. Decentralized holochain systems.
Okay.
This one sounds a bit less sci-fi
Yeah,
and more about shifting power dynamics on the internet.
absolutely. Holochain is all about putting users back in control of their data.
Okay.
Instead of relying on big tech companies to store and manage everything,
Yeah.
a holochain internet would be distributed across a network of individual users.
So it's kind of like peer-to-peer file sharing,
Uh-huh.
but for the entire internet.
That's a good analogy.
Okay.
Think of it as a giant shared database
Right.
where everyone contributes to validating and securing the information.
Right.
No single entity controls the data, making it incredibly difficult to censor or manipulate.
That sounds appealing from a privacy and freedom perspective.
It does.
But wouldn't such a system be incredibly difficult to manage?
That's one of the key challenges. It
Mhm.
requires a different way of thinking about governance and coordination.
All right.
But proponents argue that the benefits of a truly decentralized internet
Yeah.
outweigh the challenges.
Okay. I'm intrigued but skeptical.
Okay.
Let's move on to concept number 3. Space-based communication grids.
Right.
This one seems a bit more familiar given the rise of satellite internet constellations like Starlink.
Right. But imagine taking that concept to the next level.
Okay.
A vast network of satellites in orbit blanketing the entire planet
Wow.
with seamless connectivity.
So even the most remote corners of the world would have internet access.
That's the idea.
That's definitely a game changer for bridging the digital divide.
It is.
It also offers resilience against terrestrial disasters or infrastructure failures.
Exactly.
If a hurricane knocks out power lines, a space-based network could keep people connected.
Yeah.
That's a huge advantage.
It is.
But I also wonder about the environmental impact
Yeah.
of launching and maintaining such a massive satellite network.
That's a valid concern. We need to carefully consider the sustainability of such a system.
Okay, next up we've got Neuralink mesh networks.
Okay.
Now this one definitely sounds like science fiction.
It does a little bit.
Are we talking about plugging our brains directly into the internet?
Well, that's the basic idea.
Yeah.
Companies like Neuralink are developing brain-computer interfaces
Right.
that could potentially allow us to interact with the internet using our thoughts.
Whoa.
Yeah.
That's both exciting and terrifying.
It is.
Imagine being able to access information or communicate with others just by thinking about it. But it also raises some serious ethical questions.
Absolutely.
What happens to privacy when our thoughts are no longer entirely our own?
Yeah.
How do we prevent misuse or manipulation of such a powerful technology?
Huge question.
Those are some heavy questions.
Yeah.
I'm not sure I'm ready for a world where my brain is constantly online.
It's certainly a concept that requires careful consideration,
Okay.
but let's not get ahead of ourselves.
Right.
We still have a few more internet replacements to explore.
Okay, bring on the next contender.
All right, next up we have the AI-driven autonomous information ecosystem.
Okay, before you explain, let me take a stab at this one.
Okay.
It sounds like we're talking about an internet where AI is in control, filtering and managing information for us.
You're on the right track.
Okay.
Imagine an AI that learns your preferences,
Uh-huh.
anticipates your needs,
Right.
delivers precisely the information you need when you need it.
So basically the algorithm becomes our personal librarian,
Yeah.
curating our online world and shielding us from information overload.
That's a great way to put it.
Okay.
It could lead to a more efficient, personalized online experience,
Right.
freeing us from the constant deluge of irrelevant information.
That sounds pretty appealing, especially in today's world of information overload.
I think so.
But I also wonder about the potential for bias and manipulation. Who controls the algorithms that shape our online reality?
That's a crucial question.
Right.
We need to ensure that these AI systems are designed with transparency and accountability
Yeah.
so that we understand how they're making decisions
Hey.
and can prevent misuse.
Okay, on to the next radical idea.
Great.
What do we have next?
Next, we have hyperspatial networks.
Okay.
Now prepare for a real mind bender because we're venturing into the realm of theoretical physics.
Hyperspace.
Yeah.
Like traveling through wormholes and bending the fabric of space-time.
That's the idea.
This is where I start to question if this document is a serious proposal or just someone's sci-fi fantasy.
It's definitely pushing the boundaries of what we currently understand.
Okay.
This concept suggests that future technologies might be able to harness theoretical physics to bypass the limitations of traditional communication.
So we could potentially send data across vast interstellar distances in the blink of an eye.
Theoretically, yes.
Talk about upgrading your internet speed.
Yeah, but we're talking about technologies that are far beyond our current capabilities.
Okay, I'm going to file that one under intriguing but improbable.
Okay, great.
Let's move on for our final internet replacement contender, biointegrated systems.
All right.
This is perhaps the most radical concept of all.
I think so.
Imagine a living, self-evolving web built on organic computing,
Wow.
where biological and synthetic life forms contribute to information processing.
Yeah.
A living internet. Okay, now I'm convinced this document is at least partially science fiction.
It's certainly a concept that pushes the boundaries of our imagination.
Yeah?
But some researchers believe that by harnessing the principles of biology,
We could create truly sustainable and adaptive communication networks.
so we could have networks that self-repair, evolve, and even learn from their environment.
That's the idea.
Okay, I can see the appeal of a bio-integrated system,
Yeah.
but how do we actually build such a thing?
Right.
Are we talking about creating a network of genetically engineered organisms?
That's one possibility.
Really?
Researchers are exploring various approaches to biocomputing,
Wow.
using biological molecules, cells, or even entire organisms as computational units.
The biological molecules as computers.
Wow.
That's a whole new level of miniaturization.
It is.
And it could lead to incredibly energy efficient and adaptable computing systems.
Yeah.
It sounds like we're entering the realm of science fiction again.
It does a little bit.
But it's fascinating to think about the potential.
It is.
And while biointegrated systems face significant challenges,
Yeah.
such as biocompatibility and ethical considerations,
Of course.
the potential for creating a truly sustainable and adaptable internet is incredibly enticing.
All right. We've just gone through a whirlwind tour of 7 radical internet replacements,
7.
each more mind-boggling than the last.
Yeah.
But out of these 7, which one stands out as the most promising or intriguing to you?
Well, based on the source material,
Okay.
quantum communication networks seem to hold the most immediate potential.
Okay.
The advancements in quantum technologies and the compelling advantages of secure, instantaneous communication
Yeah.
make it a strong contender.
Right.
But it's important to remember that these are all speculative concepts,
Right.
and the actual path forward may involve a combination of these technologies,
Yeah.
or even something entirely new that we haven't even thought of yet.
I think that's a great point to end this part of our deep dive on.
Indeed, we've covered a lot of ground already,
Yeah.
but there's still much more to explore. Welcome back to our deep dive.
I'm still trying to wrap my head around all those radical concepts
Yeah.
we discussed. A living internet.
Yeah.
Sounds like something out of a science fiction novel.
It definitely pushes the boundaries
Yeah.
of what we currently imagine.
Right.
But remember, the internet as we know it was once considered science fiction too.
That's a good point.
Yeah,
It's amazing how quickly technology can evolve.
it is.
Speaking of evolution, we were talking about how the human brain could inspire a new kind of internet.
Right. We touched on the brain's parallel processing power.
Right.
But what's even more remarkable is how it stores and processes information
Yeah.
at the same time.
Right.
Unlike computers, which have separate CPU and memory units,
Okay.
the brain's structure with this vast interconnected network of neurons
Yeah.
integrates memory and processing together.
So it's not just about speed,
Right.
but about how the information is organized and accessed.
Yeah.
It's like the brain is constantly making connections and seeing the bigger picture,
Uh-huh.
while our computers are still stuck processing data in a linear fashion.
That's a great way to put it.
Yeah.
This interconnectedness is what makes the brain so adaptable and efficient.
Right.
It can draw on a vast network of associations,
Uh-huh.
making connections between seemingly unrelated pieces of information.
Okay, so how do we translate this biological marvel
Right.
into a technological blueprint for a new internet?
Right.
Seems like an impossible task.
It's definitely a challenge.
Yeah.
But researchers are making progress in the field of neuromorphic computing,
Okay.
designing computer systems that mimic the brain's structure and function.
So we're talking about building artificial neurons and synapses, creating a digital brain.
In a sense, yes.
Okay.
One promising approach involves using nanoscale oscillators as artificial neurons.
Okay.
These oscillators can fluctuate between states,
Okay.
similar to the way neurons fire electrical impulses.
Nanoscale oscillators. That sounds incredibly tiny.
It is. We're talking about devices built at the atomic level.
Wow.
And by connecting these oscillators together in complex networks, researchers are creating systems that can process information in parallel, similar to the brain.
It's mind-boggling to think about building a computer
Yeah.
that operates on the same principles as the human brain.
Yeah.
But what kind of impact did this have on the internet?
Imagine an internet that's not just faster,
Uh-huh.
but also more intelligent, adaptable, and energy efficient.
Right.
It could analyze vast amounts of data, make predictions, and even learn from experience.
So we're not just talking about sending data faster,
Right.
but about creating a network that can actually think.
Exactly. A neuromorphic internet could solve complex problems, adapt to changing conditions, and even evolve over time,
Wow.
similar to the way the brain learns and adapts.
That's both exciting and a bit unsettling.
It is.
It's like we're creating a new form of intelligence.
It's definitely a technology with profound implications.
Yeah.
And it raises important questions about control ethics and the future of humanity.
Okay. I'm officially adding neuromorphic computing to my list of things to keep an eye on. Yeah, keep an eye on that one.
But for now, let's get back to those 7 radical internet replacements from our speculative document.
Okay.
We've covered the first 4,
Right.
so let's jump into the 5th. The AI-driven autonomous information ecosystem.
Okay. This concept envisions an internet
Okay.
where artificial intelligence takes the reins, managing the flow of information and tailoring content to individual users.
So it's like having a personal AI assistant
Yeah.
that curates our online experience, shielding us from information overload
Right.
and delivering exactly what we need when we need it.
Precisely. This AI could learn your preferences, anticipate your needs,
Right.
and even filter out information that's irrelevant or potentially harmful.
Sounds incredibly efficient, but also a bit Orwellian.
Yeah.
What happens to freedom of choice and the serendipity of discovering new things?
Right.
Do we become trapped in filter bubbles,
Yeah.
only exposed to information that confirms our existing beliefs?
Those are valid concerns.
It's crucial to ensure that such a system is designed with transparency and accountability.
Right.
Users should have the ability to understand how the AI is making decisions and to adjust their preferences.
And what about the potential for bias?
Sure.
Could these AI systems perpetuate existing societal biases, limiting our exposure to diverse perspectives?
That's a critical consideration.
Yeah.
We need to be mindful of the potential for bias in any AI system
Right.
and to develop mechanisms to mitigate it. It's important to ensure that these systems are designed to promote fairness, equity, and access to information.
Okay. Moving on to the next contender. Hyperspatial networks.
All right.
This one still boggles my mind.
Yeah.
I'm really talking about using wormholes to transmit data.
It's definitely a mind-bending concept.
Yeah.
Hyperspatial networks propose using principles of theoretical physics like wormholes or extra-dimensional space to bypass the limitations of traditional communication.
So we could potentially send data across vast distances instantaneously, essentially teleporting information.
Theoretically, yes.
Wow.
It's a highly speculative concept, but it's fascinating to consider the possibilities.
Okay. I'm going to need a lot more convincing
Okay.
before I believe we'll be beaming data through wormholes anytime soon.
All right.
But let's move on to our final internet replacement contender. Bio-integrated systems.
This concept envisions a living, self-evolving web built on organic computing,
Right?
where biological and synthetic life forms contribute to information processing.
A living internet. Okay, this one officially wins the award for the most radical concept.
It is pretty out there.
I'm struggling to even imagine how such a thing would work.
It's certainly a paradigm shift
Yeah.
from our current understanding of technology.
Right.
But think about the incredible complexity and efficiency of biological systems.
Like the human brain.
Exactly. The brain is a prime example of a biological system that can process information, learn, and adapt in ways that our current computers can only dream of.
And we've talked about how the brain could inspire new computer architectures.
Right.
But what other biological systems could be relevant for a bio-integrated internet?
Consider the intricate communication networks that exist within ecosystems, from the chemical signals exchanged between plants to the complex social structures of insect colonies.
So we're talking about drawing inspiration from nature to create a more sustainable, resilient, and adaptable internet.
Precisely imagine networks that can self-repair, evolve over time, and even learn from their environment.
Okay. I could see the appeal of a bio-integrated system.
Yeah.
But how do we actually build such a thing?
Right.
Are we talking about creating a network of genetically engineered organisms?
That's one possibility. Researchers are exploring various approaches to biocomputing.
Wow.
Using biological molecule cells or even entire organisms as computational units.
Biological molecules as computers. That's a whole new level of miniaturization. And it could lead to incredibly energy efficient and adaptable computing systems.
Yeah.
It sounds like we're entering the realm of science fiction again.
It does, a little bit.
But it's fascinating to think about the potential.
It is. And while biointegrated systems face significant challenges, such as biocompatibility and ethical considerations, the potential for creating a truly sustainable and adaptable internet is incredibly enticing.
All right, we've now explored all 7 radical internet replacements.
7. It's been a wild ride.
It's been a wild ride through the world of futuristic technologies.
It has. And while some of these concepts may seem far-fetched, it's important to remember that the pace of technological innovation is accelerating. What seems impossible today could become reality tomorrow.
So out of all these mind-blowing concepts, which one stands out to you as the most promising or intriguing? Which one would you bet on for the future of the internet?
It's tough to choose just one. Each concept has its own strengths and weaknesses, and the ultimate solution may involve a combination of different approaches. But based on the source material and current trends in research, I'd say that quantum communication networks and neuromorphic computing hold the most immediate potential.
Okay, those are 2 very different approaches.
They are.
Quantum communication is all about speed and security, while neuromorphic computing is about mimicking the brain's intelligence and adaptability.
Exactly. And it's fascinating to think about how these 2 technologies could potentially converge, creating a hybrid internet that's both incredibly fast and incredibly intelligent.
No, that's a future I'm excited to see unfold.
Yeah, that'd be amazing.
But before we get carried away with dreams of a quantum-powered, brain-like internet, let's take a step back and consider the practical challenges of implementing any of these radical replacements.
You're right. It's easy to get caught up in the excitement of these futuristic ideas. But we also need to be realistic about the hurdles we'll need to overcome.
So what are some of the biggest challenges facing these internet replacements?
Well, it depends on the specific technology. But some common challenges include scalability, cost, compatibility with existing systems, and, of course, ethical considerations.
Scalability is a big one.
It is.
We're talking about replacing a global network that connects billions of devices. How do we ensure that these new systems can handle that kind of scale?
That's a crucial question, and it's not just about the number of devices, but also about the volume of data being transmitted. These new systems will need to be able to handle exponentially increasing amounts of data as our reliance on the internet continues to grow.
And then there's the issue of cost. Building a global quantum communication network or a bio-integrated system is going to require massive investments in research, development, and infrastructure.
Absolutely. And it's not just about the initial costs. We also need to consider the ongoing costs of maintaining and upgrading these complex systems.
And what about compatibility with existing systems? We can't just flip a switch and expect everyone to migrate to a completely new internet overnight.
That's a major hurdle. These new systems will need to be able to interface with the existing internet infrastructure, at least during a transition period. And that could be a complex and messy process.
And finally, there are the ethical considerations.
Of course.
We've touched on some of these already. But I think it's worth emphasizing the importance of responsible innovation in this context.
Absolutely. As we develop these powerful new technologies, we need to be mindful of their potential impact on society, both positive and negative.
We need to ensure that these technologies are used to benefit humanity, not to control or exploit it. We need to consider issues of privacy, security, access, and equity.
You're absolutely right. We need to be proactive in addressing these ethical challenges, not just reacting to them after the fact.
So as we move forward in our exploration of internet replacements, I think it's crucial to keep these practical and ethical considerations in mind.
I completely agree. It's not just about dreaming up cool new technologies, but about shaping a future where technology serves humanity's best interests.
I think this is a good place to pause our deep dive for now. We've explored a wide range of radical concepts, from the mind-boggling to the downright bizarre.
We have, and we've discussed some of the key challenges facing these internet replacements.
But in the final part of our deep dive, I'm eager to delve deeper into the specifics of one particular technology that seems to hold the most immediate promise: quantum communication networks.
I'm looking forward to that we'll explore the key components of this technology, the current state of research, and the potential implications for the future of communication.
Welcome back to the deep dive. Over the last two parts, we've journeyed through this wild landscape of ideas,
It has been a wild ride.
exploring radical new systems that could one day replace the internet as we know it.
From harnessing the strangeness of quantum mechanics
Right.
to drawing inspiration from those elegant biological systems.
And while all these concepts are fascinating, we've decided to focus this final part of our deep dive on one technology that seems particularly promising: quantum communication networks.
Right. Out of all the mind-bending ideas we've discussed, quantum communication networks seem to be the closest to becoming a reality.
So let's dive into the specifics.
Okay.
We've touched on the key components: quantum processors, quantum channels, and quantum repeaters.
Right.
But I'm still a bit fuzzy on how these pieces actually fit together to create a functioning network.
Okay.
Can you walk me through it?
Absolutely. Imagine you want to send a message from New York to Tokyo using a quantum network. Your message first needs to be encoded into quantum information using those mysterious qubits we talked about earlier.
Okay, so we're translating my message into the language of quantum mechanics, using those qubits that can be in multiple states at once.
Right.
It's like taking a digital message and turning it into something out of Alice in Wonderland.
That's a great analogy. Now, this quantum information is sent to a quantum processor in New York.
Okay.
Think of it as the starting point of our quantum journey.
So it's like the quantum post office.
Yes.
Where my message gets packaged and prepared for its trip across the globe.
Exactly. Now, here's where things get really interesting.
Okay.
To send your message to Tokyo, the quantum processor in New York needs to establish a secure connection with the processor in Tokyo, and this is where quantum entanglement comes into play.
Ah, yes, quantum entanglement.
That spooky action at a distance.
That spooky action at a distance that Einstein called spooky action at a distance.
Exactly.
How do we use this spooky action to actually create a secure connection?
Well, the two processors share a pair of entangled photons.
Okay.
You can think of it as like an invisible thread connecting New York and Tokyo.
Okay. I'm picturing this thread of entanglement stretching across the globe, linking those two quantum processors.
Yes.
It's like a secret tunnel for quantum information to travel through.
Exactly. Now, the quantum processor in New York manipulates its entangled photon, encoding your message into its quantum state.
So we're essentially imprinting my message onto this entangled photon.
Yes.
Like writing it on a microscopic quantum postcard.
Precisely. And here's where the magic of entanglement happens.
Okay.
Because the two photons are linked, any change made to the photon in New York instantly affects its partner in Tokyo.
Wait a minute, instantly?
Yes.
As in faster than the speed of light?
Yeah.
Isn't that breaking some fundamental law of physics?
It does seem that way, doesn't it?
Yeah.
But that's the nature of entanglement.
Okay.
It's a phenomenon that operates outside the bounds of classical physics.
So you're telling me that my message is essentially teleported across the globe?
In a way, yes.
Wow.
The quantum processor in Tokyo receives the entangled photon and measures its state, decoding your message.
And thanks to the magic of quantum cryptography, we know that my message is completely secure.
Yes.
Any attempt to intercept it would disrupt the entanglement, alerting both the sender and the receiver.
Exactly. Quantum communication offers an unprecedented level of security, making it virtually impossible to hack or eavesdrop on.
It's a brilliant system.
It is.
Combining mind-boggling physics with elegant cryptography.
Yes.
But what about those quantum repeaters we discussed earlier? Where do they fit into this picture?
That's a great question. Remember, entanglement is a delicate phenomenon.
Yeah.
Over long distances, the quantum signal can degrade, leading to errors.
Right, like a phone call getting fuzzy over a long distance.
Precisely, and that's where quantum repeaters come in.
Okay.
These devices would be strategically placed along the communication channel, acting like relay stations to amplify and retransmit the quantum signal.
So they're like booster rockets for entanglement, helping the signal travel further without losing its fidelity.
Precisely, quantum repeaters are essential for building a truly global quantum communication network.
Okay, I'm starting to get the full picture now.
Good.
We have quantum processors preparing and decoding messages. Entanglement, providing a secure link.
Right.
And quantum repeaters extending the reach of the network.
Yes.
It's like a high-tech orchestra, with each instrument playing its part to create a symphony of secure communication.
It's a beautifully complex system.
It is.
And researchers are making incredible progress in developing all of its components.
But even with all these advancements, building a global quantum communication network still seems like a monumental task.
It is a huge undertaking.
What are some of the biggest challenges that researchers are facing?
One of the biggest hurdles is developing practical quantum repeaters.
Okay.
These devices are still in their early stages of development, and it's unclear when they'll be ready for deployment on a large scale.
So we're waiting for those quantum booster rockets to take off.
You could say that, but in the meantime, researchers are tackling other challenges, such as improving the coherence of qubits, which basically means keeping them in their quantum states for longer periods.
Right, because if those qubits lose their quantum mojo, the whole system falls apart.
Exactly. It's like trying to juggle butterflies.
Right.
You need a lot of skill and precision to keep everything in the air.
And another challenge is developing more efficient quantum communication protocols.
Yes.
Which are essentially the rules for how quantum information is encoded, transmitted, and decoded.
Precise.
So it's like creating a universal language for quantum devices to communicate effectively.
Exactly. And it's a complex task requiring collaboration between physicists, computer scientists, and engineers.
It's clear that building a global quantum communication network is a massive undertaking.
It is.
But even if we manage to overcome all the technical challenges, we can't forget about the human element.
That's right.
How do we prepare society for this quantum leap in communication?
That's a crucial question, as with any transformative technology.
Right.
We need to think about the social, ethical, and economic implications.
Yeah.
We need to ensure that this technology benefits everyone, not just a select few.
So we need to start thinking about these issues now before quantum communication networks become widespread.
Absolutely. We need to have open and honest conversations about the potential risks and benefits of this technology.
Right.
We need to consider issues of privacy, security, access, and control.
And we need to make sure that we don't create a new digital divide.
Right.
Where only the wealthy and powerful have access to this quantum-powered future.
Exactly. It's not just about technological innovation. Right. It's about building a more equitable and just society.
Well, I think this is a good place to wrap up our deep dive into the world of quantum communication networks.
Okay.
We've covered a lot of ground, from the fundamental principles of quantum mechanics to the practical challenges of building a global network.
It's been a fascinating journey, and I hope it's inspired you to think differently about the future of communication.
It certainly has, and it's a reminder that the internet as we know it is just one chapter in this ongoing story of human communication.
Right.
Who knows what the next chapter holds?
Perhaps a future where we can communicate instantly and securely across vast distances using the mind-bending power of quantum mechanics.
Now, that's a future worth exploring.
It is.
Until our next deep dive, keep those minds curious and those imaginations firing.